By the end of a sourdough process, you don't actually have gluten anymore. It does appear that for many people who are showing a gluten sensitivity, this makes the bread a lot easier to digest. I see it time and time again, people who have a hard time digesting a yeasted bread, all of a sudden they start eating a slowly fermented sourdough whole grain bread. All of a sudden, it's like a totally different thing.
What are we gonna make?
Well, we're gonna just make some bread dough over here.
We're making a sponge.
We are making a sponge. The most famous one is a yeast, and it's called Saccharomyces, which means sugar fungus, and its last name is Saccharomyces cerevisiae. And cerevisiae refers to beer.
Okay.
Right? Cerveza, right? Very similar. And it's the same yeast that we use in modern times in brewing beer. And it's also the same yeast that is actually baker's yeast that you can buy in the store to make bread rise. But here, the baker's yeast, or the Saccharomyces fungus, right, sugar fungus, is living with its friends and family. So it's there with other yeast and also other lactic acid bacteria. Technically, scientifically, if you're on that side of things, you'd call them lactobacilli, and they have different last names, if you will. And a famous one is Lactobacillus sanfranciscensis. And we're interested in how they behave rather than what their names are, you know. And depending how you keep the starter. So I tend to keep mine a little bit more solid, and other people keep their starter a little bit more liquid, and they both work. You'll get a different type of bacteria proliferating in a wetter environment, in a drier environment, or or a warmer or cooler environment. Well, it's a really good question where it comes from, and I've done a fair bit of reading about it, and what I kind of love is that no one's really sure where the organisms come from. The way you start most starters is by mixing flour and water, and you just wait, right? And you can do it with the lid on, you can do it with the lid off. Myself, when I started this starter, I buried a ball of dough, which was made of flour and water, and I buried it basically in a sack of flour. And so there was no air.
Okay.
And yet the sourdough formed. That there are certain ambient organisms living on the grain. There's some in the air, there maybe are some in the water, on my hands, but there are organisms that show up in the sourdough which are not, we don't know, they're not showing up in the environment around the sourdough making site.
Okay.
There are some organisms that have only ever been isolated in the human mouth, and I didn't spit in my sourdough starter to my best of my knowledge. So it's one of those mysteries.
Wow.
You know it.
Yeah.
I fed it a couple days ago, and it's been in my fridge, so you can see, yeah, it's kind of bubbly. Mm-hmm. So there's activity, and you can see the little strings there that I'm stretching out. There's these strands. Those are what you call the gluten strands. Oh. That just shows that I kneaded my dough pretty well, and so it's formed a structure.
So you put your sourdough starter in after you've kneaded it? Like you knead it
I
and
do
then
knead
take
the starter. If I have enough time, I knead it, yeah. Sometimes I don't, but...
I never do that.
Yeah, I think it gives a message to the starter. So this is the kind of behavior I want you to... This is how I want you to behave when I put you in a bread.
Right.
It's exercising it, you know? So different lactic acid bacteria are doing all kinds of different things. So some of them are digesting parts of the grain, and then they go off and they make vitamins. So some of the organisms actually make B vitamins, right? Wow. So your bread dough could actually be more vitamin rich after you've fermented it than before you started, which is super interesting. Now, what about minerals? So the organisms don't make minerals themselves, but what they do is they unbind them. Phytic acid is a really specific anti-nutrient, which we find in relatively high amounts in wheat and other grains as well. And what it does is it binds minerals, just in normal language, what that means is it stops us from absorbing minerals. Yeah? And as long as the phytic acid is there, it's very difficult to access minerals in the grain. So phytic acid is basically one compound amongst many, many, many compounds that's found in wheat and basically in most seeds. And one of its functions is to act as an anti-sprouting agent so that the seed doesn't grow out of context, right, when it's not supposed to. And the other thing it does in the kitchen, essentially, or in relation to the human who's eating the seed, is it acts as an anti-nutrient. Right? So we often talk about nutrients. What's an anti-nutrient? So a nutrient is basically something that gives you nourishment. An anti-nutrient is something that stops you from getting nourishment. Right? So phytic acid is, in a way, it's a storage system for nutrients. Right? It has a function in the plant of locking nutrients in, which is really smart. But there's also a time and a place to unlock the door. Right? And when you're eating the food, this is the time, or preferably right beforehand. Right? So the other thing that the phytic acid does is it actually acts as a chelator. Now, chelator, the word chelate comes from claw, the word claw, and what it means is it pulls, it grabs. So from what I understand, the phytic acid, if there's a food that we're eating which is relatively high in phytic acid that hasn't been neutralized, like it is in the sourdough process, right? Then that food will go into the body and may actually pull out the same minerals that it normally holds inside the grain, but minerals that are actually inside the body. So in simple terms, a food that's rich in phytic acid, if we eat it, can actually steal minerals from our body. A person who's eating a diet that has a lot of phytic acid rich foods may be setting themselves up for a mineral depletion. And to me, that's one of the big mistakes of Western nutritional language, is that we think that what's on the label equals what you're accessing. And what this ignores is this question of biological availability. How much can you actually assimilate? How accessible is this nutrient to me? In most commercial bread, what you have is baker's yeast being used. So it's that monoculture, that single organism fermenting the mass of flour, whereas in a sourdough or a lactic acid bacteria fermentation, you have this community of bacteria that are working together. Most of the bread that's in the store is leavened or raised with baker's yeast, which is that single organism Saccharomyces cerevisiae that we talked about. And Saccharomyces is good it has a job. It's good at its job, and its job is to eat sugar. Now, in biochemical terms, when you say sugar, what you're actually talking about is carbohydrate. And in grain, you have a bunch of carbohydrate, and so the Saccharomyces goes in and it starts to digest the carb, the starchy part. What it makes are two things. One of them is alcohol, so that's why you get that yeasty alcohol smell, and the other one is CO2, or carbon dioxide. The rising is basically the yeast blowing bubbles between the bits of grain, right? And so all those little air pockets are the carbon dioxide that's been formed by the yeast. Now, that's very nice because it creates a soft, cushy bread, and it makes nice smells and flavors and things, but it doesn't necessarily break down many of the other nutrients that are in the dough. So like I said, the Saccharomyces, or the yeast, is really good at breaking down carbohydrate, but there are a lot of other things. There are nutrients that are hard to absorb that are inside the grain, right? And by undertaking a process like a sourdough, what we can do is actually unlock a lot of the nutrients that are tightly held inside the flour. Where before, it was very hard to get high protein absorption from the flour. All of a sudden, you're getting very high protein absorption, where before certain minerals were bound up. So calcium, iron, zinc, things like this were stuck inside the bread and not available for you. All of a sudden, those are just wide open. The grain is right there, and you can access it. And that's one of the things that the sourdough does that the yeast doesn't do. there does appear to be some breakdown of phytic acid that happens in a yeast dough.
Okay.
You're starting the process,
Okay.
but you're not completing it.
Okay.
Right? And to get mineral bioavailability, to be able to access the minerals that's in the bread, from what I understand, you need almost 100% breakdown of phytic acid to make that effective. Right? And that just doesn't happen in a yeast starter.
Okay.
Right? Whereas if you do a sourdough method, which takes much longer, many hours compared to 1, 2, 3, 4 hours maximum in a yeast dough typically, you can't rush these natural processes. Right? It takes time for the phytic acid to break down and happen slowly. Right? And by the time you have a fully elaborated sourdough dough, right, hopefully there's relatively complete breakdown of the phytic acid. And what's really interesting is that at the same time as the phytic acid is getting broken down, there are other things that are getting broken down. And one of those things is gluten.